So I want to talk a little bit about how this works under the hood. Now, obviously as a developer, all the stuff that I've shown you up until this point, that's what you kind of need to know. The stuff I'm about to show you is, I think, really fascinating, and interesting, but isn't really important to know. Like, knowing how it works is fun and, it can be useful, but it isn't required in order to be able to use the tools, right? You know how to install it, you know how to run it, you know how to see it and to be able to debug with it and configure Visual Studio Code correctly. That's all you really need. But if you want to know how it works under the hood, I'm kind of excited about it. So I'd like to talk about it.
Show us how the sausage is made.
Yeah, let's do some sausage. So this is the core Neo code base. This is the code base of the core Neo platform. If you're familiar at all with the layout of the Neo project, there's a VM project. That's the virtual machine that's used by the smart contract execution engine. Then there's the core Neo project, which is what we're looking at here. And then there are two other projects, the modules project, which we're going to talk about in a minute, and the node project, which is the full-blown Neo CLI node, and the Neo GUI node for end users. So one of the pieces that makes Neo extensible is that it has an extensible storage engine. So it has this interface here called iRead-Only Store. And so this is a data store that provides read access to a key value store that the rest of Neo depends on. Typically, when you're running this in production, you'll be running this on top of a LevelDB or a RocksDB data store. LevelDB and RocksDB are key value data stores from Google and Facebook, respectively. They store the data in a local folder, and that's just the way that they work. NeoExpress has its own custom data store that uses RocksDB. We use RocksDB because it has support for features that we need, like that enables us to do things like checkpoint, right? So NeoExpress has the ability to checkpoint a running blockchain at running NeoExpress blockchain at any point and save that state off in a separate file, and then later restore it or just run that checkpoint directly. We use it in the debugger. We saw it a few minutes ago. So there's a lot of different, and then that checkpoint allows you to run. If you're running that checkpoint, it can also then run in a mode where it saves all of the changes in memory and is reading all of the traditional state off of the disk, right? So when you're running a checkpoint, it saves any changes in memory, and then when the process shuts down, it throws away all those changes. So this is an interface that's defined by the core Neo platform. There you can see it was written by Eric, or at least it was last modified by Eric. And it has three operations: seek, try, get, and contains. Contains is basically all it's doing is calling try, get, and checking for null. So we can really only need to worry about these two methods. Try get says, here's a key, give me its value. And seek says, here's a key or a prefix, give me all of the other keys and prefix and values that match this prefix, and I can seek forward or backwards. So this is a very core piece of the Neo platform. So what we've done with this in order to enable Neo.Trace is we've built the ability to create a read-only store that sits on top of any individual block height in a given Neo blockchain, mainnet, testnet. If you want to run your own testnet using Neo CLI, what I'm about to show you does not work with NeoExpress, but NeoExpress you typically don't use to do this kind of stuff. If you're using NeoExpress, you're already running locally, and you can just use the debugger in its normal mode. So I'm going to bring up that shared library that I was telling you about. So we have this is called the Blockchain Toolkit library. This is a separate project that's unique to the developer, the Blockchain Toolkit. This is all the code that gets shared across the various tools. So we use this code in NeoExpress, in Neo Debugger, in the Neo Test Framework, and now in the new Neo.Trace tool. So this is what's called the state service store. And you can see here that it implements iRead-Only Store. And so what this is going to do is when you go to say, I want to create an instance of the state store, I'm going to give it a URI of an RPC endpoint. I'm going to give it an index for the height, and I'm going to tell it how I want it to cache data. So this is sitting on top of a module that ships as part of the overall Neo platform. You know what? Before we get to this, let's look at the modules instead. And do I have it open? I do not. Convenient. So I mentioned a few minutes ago that there's the Neo VM project, there's the Neo Core Neo DLL project, and then there's a set of modules. And that's the repo that we're looking at here. And so this has, let me just show you all the things that are in here. So this has the Level DB store and the RocksDB store that I was just talking about, the DBFT plugin, that's the implementation of the distributed decentralized block Byzantine fault tolerance, the consensus algorithm that Neo runs. It has RPC server. It also has the RPC client. So that way, if you're building a third-party decentralized application in C# and you want to talk to the blockchain, you'll use the RPC client, etc. You'll notice one of the things here is the state service. State service is a mechanism that Neo uses to validate everybody agrees on the state of the contract data. So every time you run a contract, it's going to make changes. Like we saw in the create sale verb, in the create sale operation, we create a sale info object, we create the account map index, we create all this stuff, and we store all that in the contract storage associated with that specific contract. The state store takes all of the contract information across all the decentralized, all the smart contracts, including the native contracts, and hashes all that to get that data together and comes up with one unique 32-byte hash. And it then communicates with the other state services to make sure that everybody agrees on what that unique hash is. You change one bit in one contract in one value or key, and you get a completely different hash. So if my node says that the hash is some value, and Dylan, your node says that value is the same, and Edge, your node says that value is the same, then we can all be sure that we all have the same value and then we all have the same contract state. It's a really important part of the overall validation story of the Neo blockchain. But it turns out it's more interesting than that. Like, it's really important that we can all be sure that we all have the same state. That's big. But it also turns out it's even cooler. If we look in the configuration file for a state service, we'll notice that it has this value called full state. And in this case, it's configured to false by default. However, the official state services that are run by NGD Shanghai for mainnet and testnet have full state set to true. The upshot of this is I can actually walk up to the state service at any time when it has full state enabled and say, what was the data at this specific height? In fact, if we look at the state service plugin, we can see here that it has a method called, where's the find states? Sorry, get state. And it's going to say, get me the root hash, get me the script hash. The root hash is specific. The root hash is going to be unique per block index. Every block will have, because if nothing else, we're adding a new block. Block is part of the contract, as part of the overall, that's stored in the ledger contract. So the overall contract information will change. So every block will have its own unique root hash. So I can say, given a root hash, given a script hash, and given a key, go get me this value. So I can actually get any historical data out of the state service that I want. Now, this is great, but one of the big features that they added in version 3.0.3 was the ability to also get multiple states. I can do what's called find states. So this allows me to also, remember when we were looking at the read-only data store, remember there was a try get, right? So given a key, give me a value, but also given a key and a direction, give me a bunch of values. I want to get all of the values that match this key. Well, because they've added that find service or find state service to find state method to the state service, we can actually now use that in a data store. That's what we do for NeoTrace. So in NeoTrace, I'll bring the NeoTrace code over here. we can actually see that we have this method here called trace block, right? Because the way that the trace works is I'm going to go off and I'm going to download a block so that I have all of its transactions, right? So I get the protocol settings from the network. I create an RPC client. We talked about, we're using the same RPC client here that you might use for a decentralized application. And I download the block, right? So I've specified the block ID. If you'll recall, when we actually here, we were doing this one before. No, let's look at this one instead. We were looking at trace transactions. So the URI, remember we said that we were looking at testnet. So it automatically knows what the testnet URIs are. And you gave it a transaction hash. So we got the settings from the network. We created an RPC client. We got the transaction from the network. And one of the pieces of information in the transaction is the block hash that's associated with it. So now we can actually get the full block. We need to get the full block because, of course, it's possible that there are going to be multiple transactions occurring before the transaction we care about tracing. So we do actually have to execute the entire block locally. We can't just execute the one transaction. So we download the block, and then we say, hey, let's go trace this block. And we only care about this one transaction that we want to trace. So then we create the read-only store. And as we were talking about, you'll see here that we're passing, like if we want to trace out, let's say we're tracing out block 10,000. Well, we want to get the state as it was at block 9,999. So we subtract 1 and we create a state service store. And so then this is all I realize that most people are probably not familiar with looking at the internals of the Neo platform, but this is very standard Neo platform code. I'm going to create this memory tracking store on top of the read-only store. So memory tracking store, it's the same kind of store we use for the checkpoint, where it will read data from this store and any changes get stored in memory, and those changes all get thrown away when the process ends. So now this is just from the perspective of the rest of the code, this is just a normal read-write data store that has Neo data in it, except that we're downloading it on demand from the state service rather than having to sync, 10,000 blocks worth of information, which obviously it takes a non-trivial amount of time. Yeah. We create a snapshot, we create the engine, we run every block has a script that runs before and after it. That's this native on persist. We run that script. And then we walk through every transaction in the block and we execute it. We use we call this function called get engine. We actually use a special trace engine if we're doing a trace. This is part of the Neo blockchain toolkit because we actually support tracing not only here, but also in Neo Express. When you go to execute contracts in Neo Express, you can also specify that you want to generate a trace file. So this is just a shared piece of code that does that trace information. You just, tell it what the file that you want to use is, create this trace debug stream and pass it to the trace execution engine. And then we just run it. And then if it succeeds, which is to say it halts, we commit. Otherwise, we blow away any of the changes if we fault. And then we're done. So it's actually, as you can see, it's actually a really small amount of code. The magic is all in both the state service store and in the state service itself that the store is built on top of. Note, in this case, we're talking about store as a data store, not like the app store. I can tell by your stunned silence that you are flabbergasted at this.
Blown away.
Very impressed.
Absolutely. Yeah. Obviously, I'm not much of a developer. I convert engineer speak into human speak, but it was really cool to see the process using the example of the safe purchase sample, and then kind of understanding how the Neo blockchain itself, version 3.0.3, kind of makes this all possible from the back end.
Yeah. And we think that there's some other interesting things that we can do with this technology that we're not quite ready to talk about yet. But obviously, one of the cool things here is that, as I said, is that I can actually, get a view of the blockchain at any height without having to do a full sync. And, there's some interesting ideas that you can do with that from that perspective.
And granted that your steeped in the Neo blockchain and the Neo ecosystem. I'm curious to hear your perspective that other developers and other ecosystems might have. Is this tooling available? Is this something that is unique to Neo? Do you have any insight into that?
So we've talked a little bit about my history. I actually don't have a giant history in blockchain before coming to Neo, so I can't really comment about what other platforms have. I do know that other platforms have, the ability to generate traces. I don't know whether they have the ability to generate traces like this. The other tools that I've seen in other ecosystems, the tracing is built directly into the node. So you can walk up to the node and say, hey, I want you to generate a trace of this transaction that occurred. But that, of course, requires the actual node to be running the right code that generate the trace. What I think is unique here is the part where I can actually run it locally. So, which actually then, of course, I mean, you're taking up resources to retrieve the data from the state service, but that's it. Everything else is your own local resources. And in fact, you can imagine if you wanted to, if you wanted to trace every block that occurred on the blockchain in the entirety of history, you could write a little batch file that says, run NeoTrace. As I think we mentioned here, let me go back here to here. So I can actually run NeoTrace. Of course, I've got my really long command prompt here, which makes it a little harder for everybody to see. So we did NeoTrace before using transaction, right? So we can say here NeoTrace transaction and give it its transaction hash. Well, as it turns out, you can also do it by block, right? So I can say .NET NeoTrace block. I was trying to copy and paste a block number in here. And it will then trace out every transaction in that block. This happens to be the block where I deployed the safe purchase contract. So it will have a single, we now see we have three, the 474747, which is kind of an interesting hash in and of itself. That's the hash of the original deployment of the contract. So if I copy this, let me just copy this relative path, and we go back into the launch file, and I say, hey, let's change this to this one here. Let's really go without a net. Let's see what happens here. You can see here now we're actually tracing through the deploy method. So I just traced out that whole block. Obviously, we're still in the migration phase for Neo N3, so we're not seeing as much traffic on Neo N3 as we're seeing on Neo Legacy yet. That will obviously change over time. So this block, plus it's testnet. So, there's obviously going to be very different traffic on testnet relative to mainnet. So this block only had the single transaction in it, but I was able to trace out the entire block with just a very simple command. So you can imagine building a tool that just said, hey, every 15 seconds, go trace out the next block. And I could actually create a trace of every single transaction that has ever occurred on the Neo blockchain. But I'm doing all of that work locally. So I'm not actually taking up, like if you were to do that against, if I was going to ask the node to do this trace file for me, that would take up a lot of resources for the actual trace. Getting just the data from it. And of course, as you can imagine, it's only retrieving the data that it actually needs. The way the state store works, it goes off and retrieves the data on demand. It does not retrieve all of the data, of course, because that would, kind of violate the purpose. The whole point of it to be able to do this with downloading the least amount of data. So I'm not downloading, like if you have a contract deployed on the blockchain, I'm not downloading your data. I'm certainly not downloading, say, the full ledger contract or the full contract management contract or any of these other contracts or like all the Neo, like even syncing testnet at block 10,000 or 100,000 of the Neo contract takes like 30 seconds if I was going to try and download just the full contents of the Neo contract locally, because of course it can take a while because of the fact there's just a lot of data, all of the voting information, all of the contract information, all of the token balance information. Yeah, I don't need 99.999% of that, so there's no point in downloading it. So I'm only downloading the very small data that I actually need to execute the specific transactions and the specific blocks. We are caching that information locally. So if you go to retrieve the same information multiple times, we only retrieve it once. And in fact, we even have multiple implementations of that caching so that we can actually cache it on disk or in memory. Now, for something like NeoTrace, where you're just going to run the tool once and generate the trace, there's no point in caching that data locally on disk.
Right.
But as I said, we're thinking of other things that we might do with this technology over time.
Mm-hmm.
Cool.
So is a priority for you then the next step, getting this integrated with the visual dev tracker into the GUI?
Yeah, I think it'd be really nice to see this in the dev tracker. It'd be nice to be able, obviously with there's some UI bits of the dev tracker that are specific to Neo-Express versus say mainnet or testnet. Mm-hmm. We have a special, for example, there's a special operation JSON RPC endpoint for Neo-Express to proactively tell Visual Dev Tracker which blocks are empty or not. So that way the dev tracker doesn't have to bother to request empty nodes or empty blocks, just as an optimization. And so there's a UI that you can say, hey, I want to hide all the empty blocks. You could imagine, because again, we do not keep full state of Neo-Express. There's no point to that. Mm-hmm. We blow Neo-Express can get blown away at any time. There's no point in trying to keep the full archive history. We don't implement the state service at all in Neo-Express. So Neo.Trace will not work with Neo-Express at all. But you can imagine that since we already have the ability to to explore, we get a nice, explorer view of both mainnet and testnet. It would be relatively simple to add like a context menu that says, if I click on a transaction or I click on a block, hey, trace this out. Uh-huh. Right. It would be a relatively small amount of code to add to Neo Dev Tracker. We just haven't gotten around to doing that yet. Cool. But that does sound like a really good suggestion. It's almost as if somebody on this call could open up a bug on the Dev Tracker GitHub repo. Somebody who is not me, because of course it's always great. One of the things that's really great about working with you guys and working with other folks in the community is this is a community project. So it's actually really valuable to have folks that aren't me opening bugs, folks that aren't me fixing bugs. And it's like we recently added some code to the blockchain library for the for the test library that had come from a third party. And so I was really excited obviously most of the code comes from us, but it's always great to get developers from the community involved in the project, whether it's, fixing typos or writing full, subroutines, all of it. We're really excited to get it. And so, you should go follow Bug Edge.
Yeah, we'll do.
Feature request, I guess. But, not really a bug, but same difference.
Yeah, I got one question for you. Just during the state service store, you fetch the correct node state for the previous block, and then you grab the whole block that has the transaction that you want to capture the trace for, and then you replay each of the transactions within that block. Is this so, for example, if I have one block where I invoke a contract 5 times, and maybe it just does something simple like increments a value, so if I then capture the 5th trace, even though we got the state from the previous block, like because we're replaying those previous transactions that we aren't tracing, it means the 5th one that we do trace will actually have the correct information. Is that why that's done?
Yeah. So, I mean, the primary thing that any blockchain does, Neo, any of the other ones that are out there, is essentially to create a ordered list of transactions. Mm-hmm. And those tend to be grouped into blocks in most blockchains. But the key thing to think about is it's the transactions. I care about tracing this transaction, but that transaction depends on the state of every transaction that comes before it.
Yeah.
However, the state service works at the block level, right? So I can't get I can get the state as it looked at block 10,000 and at block 10,001, but I can't get it at block 10,000.5, if you will. Like,
yeah.
So in order to make sure that the state locally matches the state as it existed, in the blockchain when a given transaction occurred, that isn't the first transaction of the block, we have to execute all those transactions individually. That does kill the performance a little bit. That's part of it. Look, I'll be perfectly blunt. The very first time I prototyped this, I didn't actually prototype it as a command line tool. I prototyped it by integrating it directly into Neo Debugger. The problem is that that's great if right now, like in testnet, like, tracing out this block is pretty fast because it's the only transaction that's in it. But if you have there are dozens of transactions in every single block running on mainnet for Neo Legacy, and obviously we'll be in the same boat for N3 production mainnet sooner rather than later. So I don't want to have the developer to have to pause the blockchain, the debugger for 30 or 40 seconds while it downloads and executes, 5 or 10 transactions that might have occurred before the one that they care about tracing out. So that's the reason why we actually did this as a trace tool rather than integrating directly into the debugger, because that developer experience, as soon as it gets any slower than it is right now, which it will, of course, as the number of transactions that are occurring on the given blockchain increase, it makes for a pretty poor developer experience. So that's the reason why we chose to go the route of making this a tracing tool as opposed to integrating it directly into the debugger.
Yeah, it makes sense.
Yeah. So, but yeah, because otherwise, like you can imagine, like, for example, like in this specific contract we were looking at, I'm transferring Neo. Well, like if I had, if I'm transferring 200 Neo into this contract and I had 300 Neo, but I spent, but there's some other contract that got, or some other transaction that occurred in this block before mine where I sent, 150 Neo to Dylan, then the result of executing this contract is going to be very different.
Yeah.
And so, and since, unless you're going to do a bunch of analysis to try and guess whether or not a given transaction in the block before this one is going to affect this one, and I don't know if there's any real analysis that you can do for that other than just run it. And, so this tool will get slower as it's hitting blocks that have more transactions in it. But again, it's the kind of thing that you run once and then, so if it takes 30 or 40 seconds to run, we can add a progress indicator to it. But the whole reason it's designed to run offline is in order to make for a good developer experience while you're in the debugger, where that experience really matters. Like if your debugger just, pauses for 30 seconds, you're not going to be very happy.
For sure.
Other questions?
You got anything, Dylan?
I don't think I have any other questions, but I do think a great way to end this stream would be calling on the people who are viewing this video, whether you're a developer or not, to make comments or to pull requests to not only the work that Harry's been doing with NGD Enterprise, but also with the other developer communities, because that's a great point that you brought up, Harry. And something I've always appreciated about you since day one is that this is a community project and these are community tools, and you've always sought input from the people that are using them. So I think that's sort of a nice way to end on this, to call on people to make comments, whether it's correcting a typo or asking for a simple solution or for a solution for something. Like Neo.Trace is the product of the first request that was ever made of the Neo blockchain toolkit, which I think is really cool. Of the debugger, sorry. Yeah. Which I think is really cool and just highlights the fact that, if it's kind of the field of dreams metaphor, if you build it, they will come. Like if you ask, there might be some response. So
there's some great, and there's some really cool features across the blockchain toolkit that came from the community. I'll be honest, I spend my time building tools. I do not, in fact, spend my time building D apps primarily, right? I build these sample D apps, but building a sample D app and being a real D app developer are two very different things. So one of the things that came up during the hackathon was, hey, I really need to be able to have a D app that runs on my mobile phone, and I'm trying to test it. And by design, for security reasons, NeoExpress does not communicate off machine. That's by design. So we added that. So one of the things that you can do is you can now configure NeoExpress so that it will expose its RPC endpoints on your public network, on your local network, obviously. So you can now say, oh, look, I have my iPhone app or my Android app, and it's communicating with NeoExpress running on this machine. And that was a feature that got added because of requests from two completely separate people. So two different people came and said, hey, we really need this capability. And I'm like, as soon as if I hear it from one person, I think it's a good idea, I'm going to do it. If I hear it from two people, then it's like at the top of the priority list. So I love getting requests from people who are actually using the tools. I don't want to sound like I'm bragging, but I'm a pretty good developer. But there's a difference between being a good developer and being steeped in the actual usage of the tools day in and day out. And there's actually a letter on both the debugger and the Express repos that talks about the fact that these are all built from my perspective. And while I like my perspective quite a bit, I think it's pretty valuable. As we've talked about in this podcast, different people approach the problem different ways. And some people like GUI tools and some people like command line tools. Some people are really protective about the global state of their machine, and some people are less concerned about it. And so like the more feedback I get from especially people who actually use the tools, the better I can make them for everybody.
And even that example that you just gave about exposing the RPC endpoint for Express, we recently released the a gas bot for the Neo subreddit. And one of the things that we used a lot during testing was Express. And how did we do that? Well, we did it the same way that we do it through production, which is we're interacting with the network through RPC. So without someone coming forward and suggesting that feature, we wouldn't have been able to do that.
Yep. So there were people who actually, before we implemented the feature, there were also folks on the Neo Discord who are figuring out how to do that with like a proxy server. So you could set up a proxy server that you could connect to the proxy server and it would connect to NeoExpress on your behalf. And then we eliminated the need for that extra complicated step by just supporting it directly in NeoExpress. So not only did we get the great feedback from the community to add this valuable feature to the product, we also had people who were able to help customers work around the problem in the shorter term at the time to be able to enable the scenario before the tools actually supported it directly. And that's the kind of stuff that I love about this community in general.
Cool.
Awesome. I think that's a good note to close the session out on.
Sounds good.
Yeah, thank you so much for your time, Harry. It's been really educational. Learned a lot of things about how all this works. So yeah, excited to put it to use.
I'm excited to hear people putting it to use.
Sweet. Well, thanks for giving us an hour and a half of your time. I know that it's quite valuable, and hoping a bunch of people find this video as useful as I'm sure Edge and I did.
I'm glad to hear.